Darren, what's going on?
I'm just sorting out a slight leak on the power steering return, low pressure side. She's tuber clips pulled through the hose, it's an old hose, and it's leaking, so swapping her out. So we can have some power steering then, because it's a bit heavy moving it around at the moment.
So we're inside the car here now. I got the laptop turned on, we're hooked into the ECU. So before we can really do anything at all, the most important thing we've got to get working to start with is the triggering. And by triggering, I'm basically referring to allowing the ECU to effectively know where the engine is, so where the crankshaft is in revolution in the cycle, in the 4-stroke cycle. So as I think I've explained in a previous clip, the crank itself has got a sensor on it with a 60-2 tooth wheel on the flywheel. So this is our trigger 1, which we're going to be using for the ECU to see the position of the crankshaft itself. And then we'll then use a reset from the camshaft, from a hall sensor on the pulley for the camshaft. So effectively that enables the ECU to know which of the 2 revolutions of the crank the engine is in. So where in the 4-stroke cycle it is, because obviously the crank goes round twice for every cycle, so it needs some sort of reset to know what's going on. But firstly, the first thing we need to get going is the reluctor sensor on the crank itself. So that's a 2-wire reluctor sensor, so it relies on the pulse of the metal going past, the gap going past the sensor to create current. Now the nice thing about this ECU is it does have a built-in scope. So I've got this open now. I've just got one input turned on, and it's connected straight to the trigger 1 ADC. So as I motor the engine now, we should get a signal from that sensor. Obviously I've already tried this and we do. I had to actually reverse the polarity of it to make it the correct way round. So if I turn the key now, the battery's getting a little bit tired. So you can just see it stop there on that trigger point. So what you can effectively see there, so every time you see the wave go up and down, that is every time one tooth goes past the sensor. The reason for the varying width and stuff here is because the engine is speeding up and slowing down as it's motoring every time it goes over a compression stroke. And you can see in the middle there's a gap, so that's where the 2 missing teeth are. So you've effectively got 57, 58, and then it'll be miss 2, which will be 59, 60, and then back to number 1 again. So that gap is where your 2 missing get. So that is your crank reset point effectively, as the crank's going around. So if I actually bring up I've got on trigger 4 now the process trigger inputs. So this will effectively tell us what the ECU is seeing as a trigger and what it's not. So we're set up using the falling edge on both sensors. So basically every time the ECU sees the falling edge of that wave, it sees that as a trigger event. So if I motor the engine now with the process views, we should see some processed trigger inputs going on. Okay, it's a bit hard because I should have offset that top one a little bit. If we just move that first channel up a little bit so we can actually see what's going on here a minute. Like so. So we've still got, I just left on channel 1 the raw input, so you can see there's our -2. So then we've got trigger 1, trigger 2 going on here. So again, you have to kind of ignore the varying widths. It's because the engine's running or motoring unevenly. But effectively, you can see, if we look up here where we've got the 2 missing, it aligns with this obviously bigger gap here. So that is, and if you keep rolling down, you'll see on the falling edge of the missing gap, it's seen that and it's picked it up as being a miss 1. So it's picked that up successfully as being a trigger point. Now trigger 2 is the hall sensor on the camshaft, and if you just look right towards the end there, it's just picked that up. So obviously that will only trigger once every 2 crank revolutions. So we just motor a bit. Right, I've just adjusted the time base slightly now, so now each one of these lines represents 100 milliseconds rather than just 20. So we've got a bit more going on here at once, so it does enable us to see a bit more what's going on. So here's the raw process trigger input. So there's your crank, you can see lots and lots and lots. There's the miss 1. You can just see on the thing there, trigger 2, and that's where your camshaft hall effect sensors is skipping out. So there's your main reset, so you know there, and obviously it's then followed by the other one. So I can see there now quite happily that both sensors are giving me good signals and I'm getting what I need back. So what you can see in front of you is a complete bodge up that I've just made to, I think I mentioned in a previous video that once I got it running I was going to then go ahead and get a timing light on it to confirm that my timing is definitely correct, or my triggering is definitely correct. So I expect there's quite a lot of people familiar with using timing lights on petrol, so for anyone that isn't familiar, basically the light is used to determine timing on normally on a petrol engine. So you basically just connect your timing light to the battery, and then it's got an inductive sensor that you put over a HT lead. So basically what happens is every time that plug fires, that strobe is also fired. So if you then point that at your timing marks on your crankshaft or your flywheel, wherever they might be, that will then flash and line up with whatever at that point in time. So if your engine, for example, if your engine is sparking the plug at exactly 0 degrees all the time, which I know normally running it's not, but generally any ECU has a timing lock feature to enable you to tick a box or click a button and it'll lock the timing at 0 degrees, which makes it a lot easier to set your timing, because you can then use a true top dead center mark, which is what I've got on the side of this engine. So the plan is to obviously hook that into one of the ignition outputs on the 1280, because it is obviously originally a petrol ECU, so it has 12 ignition outputs on it, which is ideal. So we'll use ignition lock 1, set the timing to 0 degrees, and that will then enable me to point this at my crankshaft pulley on the driver's side of the engine, where, if you remember in a previous video, we made some marks which at the time probably looked a bit pointless. Well, this is what they're for, because you can see that really easily when the engine's in the car, whereas you can't see the flywheel very easily. So the idea will be get this up and running, confirm that this is definitely triggering at 0 degrees, which is ideal because the software actually has a timing lock feature for doing exactly this in a petrol. I can then point that in there, and what I'm basically looking to see is to make sure that that line is lining up on the crankshaft pulley exactly in line with the line that we made on the side of the engine when it's at 0 degrees, because that will then confirm to me that I've got my triggering correct, and when the ECU believes it's at top dead center, the engine actually is at top dead center, which is really important, because if you get that wrong, effectively your entire injection table is incorrect, because it's all going to be offset by however much this is wrong. So it's kind of a waste of time going ahead until you're 100% sure this is right. So what we're going to go ahead and do now is get this hooked up to the car and just turn it over, and we should hopefully straight away see, well, our little spark tester flashing, and also if we hold the trigger we should see the timing light flashing as it's motoring. And if we do, then we should be good, so we can go underneath and see what's going on. So I got the front wheel taken off the car again now, and it's jacked back up again so I can get in and have a look at this timing mark on the end of the crank pulley. So you can see we've got the timing light contraption that we made up on the floor all plugged in inside the car. So what we're aiming to achieve here, if we can see what's going on, I'll just get a light so we can see if the camera's going to focus. Okay, so just move this pipe down out of the way so we can see what's going on here. On the end of this crank pulley there is a mark which is somewhere, I can't tell, it's just behind that hose there, you see that scored line. That's actually just a rough line, so I have a rough idea where the main mark is, but on the back side of that pulley there is a notch in the side of the pulley at the back. It's hard to see on the camera. That basically lines up with the scored mark you can see on the tip of my finger on the timing belt case. Now those two lines mark up at top dead center, cylinder 1 ready to fire. So the critical thing we need to make sure here is that when the ECU is giving a 0 degrees angle output on ignition 1, those two lines should be lining up with the timing light. If they're not, then I've got my angles wrong and we need to confirm. Right, I think it is about time for the obligatory sort of first fire up video. Now, I'm not going to lie, this is not the first time, obviously, that I've had this running. It's kind of been a bit difficult to do that, mainly because obviously there's so much more to think about with this engine compared to the last ones, where really it was just a case of putting power to the solenoid and I pretty much knew it was going to run. There's been quite a lot of messing around, getting the triggering and stuff sorted out, then sorting out initial timing values. So I'm at a point now where I'm able to actually turn the key and it should fire up, so I thought I'd capture that on camera a minute. Hopefully you can hear what's going on. I've got the extractor on, obviously. So I have had it running a minute ago, so it's all up to temperature. So to come inside the car for a second, we've got everything set up now in the logic so that it will fire that number 1 cylinder at 0 degrees. Obviously in a real situation you wouldn't want it doing that, but in this particular scenario I just want to be 100% certain that we're triggering at the right time before I go spending any time. So if we fire the engine up now, it should be triggering that leading plug number 1 at top dead center. So we'll just turn the fuel pump back on again in a minute. Hopefully you can still hear me. I've got the engine running now, so you can see. This is a quick visual test to make sure that ignition output is working. You can see that it's triggering the bulb in the HT lead there. So if I now turn off this light, that will mess things up. If we just come in now with the timing light, see if we can see. I don't know if the camera's going to pick it up, but I can see the 2 lines are absolutely 100% in line, and the timing is stable. So that is a good sign. It means everything's working as I expected it to, and the ECU is in sync with the engine. Thoughts, Darren? Just firing up. Could do with a little bit more time, I think. It starts with all that's going on.
You having fun there?
Fuck's sake. No. Fucking dirty job.